Gotta add 273 because the units are in kelvins. That has to switch.
Okay. I'm pretty sure she said that.
Yeah, I feel bad for her because every day she has to tell Adrian to sit down, and then she yelled at them, "Shut up! Stop talking!"
Here I come. Tell my God.
No.
Hannah, would you put the procedure sheet?
You keep talking. You never get your work done.
I don't have it.
Oh, yeah, you do. I ought
Me too. I can help people around me every single day. Because nobody knows what to do. Even though it's so easy.
Sometimes you're really frustrated in class. Not all the time.
I get really frustrated that the teacher just sits there and copies my work. She literally sits right next to me, falls asleep, and then wakes up and copies everything on my paper.
And then you'll be like, stop, like, why are you on? She's like, I'm not copying.
Oh, okay.
And then she tells me I was copying her, and I'm like, how would I get paper cut?
So just keep that. It's like plug and chug.
I don't mind people copying off.
Okay, I'll try to put the temperature in
When they
heat.
have like,
So it would be like
Yeah.
more algebraic.
Yeah, just like the physics. Just like
we do this, I always sort of do the problem, sit next to her, and like, do this on my paper every
One of my pet peeves is people fall asleep and they ask you how to do it. Like, you should have been doing anything. It's not my fault.
I've never done that. Sometimes like done that.
Sam, how you doing?
Well, whenever we were in probability, I fell asleep in class like so many times.
Bad boy, I'm fucking.
I only fall asleep.
Oh, English I was not one day. And strangely enough, I fell asleep on my guitar once in the car.
Just like,
No, like I was just like laying
I'll be like,
between the little trees.
There's always something new for us.
Okay, so on the board up here, write this question down. I'm gonna come around and check homework. If you have this answered down, it's like one more that you have to write on your homework. Isn't that amazing? I'm such a giver.
that's great.
Which problem is that?
No, I think it's number
Yeah.
number 3. Because 3 is a
No,
number.
Aren't we all? Like humans
No,
in
you all
general.
don't sing.
I play.
Well, y'all don't like play like in class like she's humming.
Between 2 and 4.
That's my notes is choking.
Like that. It's like,
We'll see my geometry teacher.
Now don't forget you have to add 273 to
This
this.
is my son.
Has to
But
be in
I'm
Kelvin.
fourth period. He's like
Oh, I don't know the
Yeah,
add.
yeah, you have to add it to
like the third or
750.
fourth page of notes, so it's like 8 pages of notes. And he'll go, we're gonna stop here because this is about as far as 50 we will get.
We don't have.
And he hasn't even had to read it.
I like the way that this V does notes, and she gives us like a paper, and we just fill it in and all that.
After the notes, we're just supposed to sit there, no tablets, no talking, no.
what is that? Is that pen?
No
Don't
moving.
You
forget I
can't
put
tell
it
you
in
go
bold.
No, like, we're not allowed to like move out of our seat.
Get out.
Leave my classroom.
But
You have like an
say-
allergic reaction.
you say-
Fine now.
Say we're
You're seizing on the floor. He's just like, what are you doing? Shaking on the floor.
But he's
After the notes, we just do practice, and then after that, if you don't finish it, it's homework. Although sometimes she says you have to do it. It's like if you're here, you have to turn it in.
Yeah, but then you just turn it the next day and she's all cool. So.
And then sometimes we think, like, in our class, we always stop like 10 minutes with a bell. But
Yeah.
she thinks it's gonna like interfere with her plans. I don't know what she did. Like, we're stopping here because the bell's about to ring. It's like 10 minutes.
I would all like that.
No,
For
because
us-
like my teacher, like he goes so in depth to something that like once you start like another problem, then like it'll take a bit.
Okay, so what is the answer, Michaela? Is it spontaneous or not spontaneous?
It is spontaneous because it's negative.
Yes. She is correct. It is spontaneous because it is negative. Now, just remember that like when you pursue like work, they want you to label your numbers.
Today.
So you've got to get used to doing that. When you go to the workplace, you just can't put numbers down. They'll freak out on you. They're like, what is that? Is that like inches, feet, boxes, clothing, t-shirts?
What how many count is just money?
Yeah, especially when you go into management, like you see like opening like at McDonald's or wherever you're going to work, managers, they deal with numbers. Yeah, McDonald's is a good place to start. If you can own a McDonald's, you can make a lot of money, so don't
I'd
dismiss.
rather own a Chick-fil-A because they make even more money.
Yeah, don't dismiss any workplace. Never dismiss wherever you're going to start working.
The person mixing the concrete the concrete dust not strong enough for its purpose.
For example, NO2 represents the lower concentration of NO2.
Alright, so we have average reaction rate, initial rate, and instantaneous rate. So what do all three of these different variables have in common? Right. So you need to understand that when you hear the word rate, the units that you're going to be associated with are what? Mole per liter per second. Right? Like you see right here in the book. Mole, liter, second. So over here on the following page, they're showing you how to do that. So you got average reaction rate equals the change in the reactant divided by the change in the time. So for this one, it's going to be change in reactant or divided by the change in time. But you have to remember that whenever you hear the term rate, somebody has a clock and somebody's timing the reaction. Then we get into orders like a zero order. Anybody ever heard of a zero order reaction? Jake, what's a zero order reaction? It's a reaction that does not change regardless of whether you increase or decrease the reactants. So it has no effect. Now, that's not true on some reactions. You can add more and it will go faster. You can change the concentration, that is, instead of it being like a half a mole, if you added 3 moles, it could make it go a lot faster. This is true with acids. Acids are just a lot more, I guess you would say, aggressive because they have that proton to donate and an electrons to accept. So be aware that you can make things go faster by changing concentrations. And that's things that we're concerned about. Speed is very important, as we looked at the beginning of the chapter here with these pictures. If you win, you tend to get scholarship opportunities. And you win by being what? So that's the F. Fast. Yeah, I already did this because you got to change it to Kelvin. This is Celsius, so you add a 273, gives you Kelvin. So it's 1023 Kelvin. So basically you have this minus parentheses, this times this parentheses. You have to multiply these two numbers. In doing so, your Kelvins cross out and you're left with J mole. Right, so once we multiply this times this, we got 152,324. That's joules though, and we need it to be in K joules because it has to be the same unit to subtract. Make sense? Yeah, so that's going to be your minus. Yeah, divided by 1,000, so that's going to be, like you said, 152. .32 kilojoule per mole. Now my last student, last period, she didn't write down the units. If you remember that, you go back and look at the video. She didn't put the units here, and that's why she made a mistake. Because the kilojoules have to be the same to subtract, so go ahead and subtract the two. Now the reaction is going to be negative. So what does the negative reaction tell you, Rain? That it is spontaneous. Negative tells you spontaneous. Good though that you were thinking, you understood that. It was either spontaneous or non-spontaneous. And then kJ per mole. The units have to stay there. They follow through and make you understand what you're doing. Units on there. Now, public service announcement. The yodeling boy will be at Walmart Bassford Manor today. I'm not really sure why they don't have a name for him and why they call him the yodeling boy.
Because he's the yodeling boy.
Why can't he just have a name? Why don't they just call him like by his name instead of the yodeling boy?
Yeah, no, I follow him on Instagram.
No, I've got somebody out. You gotta wait till dying gets back. That is correct. Then you gotta do minus T. You gotta change the temperature to Kelvin.
Minus 1, 5, 2. So then I
Make sure you put the units there. The K's did cross out because this K right here crosses out when you multiply times the temperature right here.
Okay, since this is kilojoules and this is joules,
Right.
do I have to, I multiply one of them by 1,000?
You have to get rid of this into kilojoules. That's a good point because you can't
I
subtract
multiply
it.
this by 1,000? Or
Well,
this one?
what you'll do, if that's joules, right, that's in the top, you're gonna wanna, where's joules gonna go to cross them out? Top or the bottom?
Bottom.
Right. So 1 kilojoules, how many joules?
1,000?
Yeah. See that how then they'll cross out? So you gotta divide by 1,000.
Kilojoules over mole.
Yes. And is it, what does that tell you? What does the answer tell you?
That since it's negative, will be, hold on, isn't it spontaneous positive? No, spontaneous negative.
Spontaneous is negative.
So it will be spontaneous?
Yes, it'll be spontaneous.
Indicates a change in the quantity. In equation form, average rate or speed is written as follows. Figure 16.2 shows how a reaction proceeds from reactant to product over time. Notice
The book brings up 3 different rates in the chapter. So what do these 3 have in common? So what does that mean? They all have the same. They all have the same. What's this right here? Starts with a U. Yeah, they all have the same unit. Now, mole per liter. You might know what mole per liter is. It's called molarity, moles per liter, right? If you add seconds there, you're talking about its movement. So movement time is associated with distance divided by velocity. So as this reaction goes, you got seconds there. Now, why is this liter in rate? Last question. Why is liter in rate? Why is liter in rate, Kaylee? Why is liter in rate? Because most reactions happen in chemistry are in water. So when you go into a chemistry lab, you're going to see a lot of water. And with the water, you can change the temperature of the water. You can do things. Most water basically separates the ions, and the reactions can go. So reactions typically happen in water. You're made of water. Now, in the book, we're going to look at reaction rates. There's the book talks about a 0 rate order. What does that mean? 0 rate order. Well, rate order has to do with if you change the concentration. Like if you have 1 mole of acid compared to like 0.5 mole of acid, which one do you think is going to make it go faster? 1 mole or 0.5 mole? You ever heard of liquid fire? Yeah, liquid fire is like a plumber liquid that you can pour down your sink. The problem is though, if your sink, if there's any metal in it, it can actually dissolve the metal, sulfuric acid can. So you want to be very careful with it. I don't recommend using it just because it's dangerous. But the more concentrated the acid the reaction will tend to go faster. I don't know if you've been following the news with Hawaii. They're talking about acid rain there. What are they telling you to do if it rains on you there? Yeah, they want you to take a shower because it can get in your eyes and that can cause irritation. Could it cause some vision loss? Maybe. So, liters, if you have a 0 order reaction, changing the concentration will not affect the rate. So like a salt, if you added more salt, could it go faster? Probably not in a non-living thing. In a living thing, it probably would affect you. Like if you added more salt to your diet, it's going to affect you. Now that would be multiple reactions, but we tend to be specific in chemistry, and you're not going to see a situation like that. But just bear in mind that if you have a zero order, it's not going to affect how fast it goes if you change the concentration. That's what I mean by zero, no change. Make sense? Zero. Can you have a negative order? Yes, and it can actually slow down the reaction. They say retard, but that was back when the R word wasn't used a lot, and everybody wants to come in science and take words and make them into bad words. Yeah, so it can actually slow the reaction down. Some things. Is National Student Day. So I got some apples for you. I know it's supposed to be like Teacher Appreciation Week, but I, from now on, recognize this Friday on National Teacher Week as Student Appreciation Day, because y'all been so nice to me. I just want to say, right back at you.
Okay, we're gonna multiply. Are we correct so far, Mr. Steiner?
Okay.
Okay, here we go. That was the number we got. Okay.
Now write that down. Do your 135.5 minus that.
Okay, 140. What?
This unit right there. I should have put that there. And in the long run, you can't do math, addition and subtraction, if the units aren't the same. You see what I'm saying?
Mm-hmm.
So if this is joules and this is kilojoules, you can't subtract. In math they teach you can't subtract apples from oranges. They have to be the same thing. So you're going to have to convert this J mole into kilojoules.
So
that's going to be mole.
Kilojoules?
Yeah, you got to convert joules to kilojoules.
So that's kilo means 1,000.
Yeah.
So how many places do we have after the decimal?
Well, do the math in the calculator. I'm going to Walmart.
What the heck?
Can you yodel for us real quick? Oh, he does look like him. He's the yodeler.
Make no face.
The kilojoules, because the units are in kilojoules.
Yeah.
So you're gonna take that. What's going on the bottom? Joules or kilojoules?
Mole. Kilojoules.
How's joules gonna cross out the kilojoules on the bottom?
Joules.
Right. So we got 1 kilojoule is how many joules?
Oh, I don't know.
1,000. Kilo means 1,000.
Oh yeah, all right.
See how the joules cross out now, and you have kilojoules. So you got to divide this
1,000 by
answer to get rid of the kilojoules.
The whole thing?
Well, I would do this math first,
All right.
and then divide it by 1,000.
And should it change science first or afterwards?
Well, this is going to stay kilojoule per mole, and now you've got kilojoule per mole.
Talking about the sign. Should I change like -7 or
No,
do it
it's
afterwards?
still going to be minus. It's still going to be minus 750 plus 273 times 148.9 divided by 1,000. And then you're going to subtract that from 135. And the units will be, make sure you write it down. Right here.
Oh, so it's negative, so it's spontaneous?
Very good. Makes sense?